All right, welcome to the matrix. A matrix is a set of numbers like this that are just in a nice organized little fashion. Now this could be, for instance, a seating chart, and 2 apparently is his class number, this kid's number is 7, that's a pretty lucky kid. This one, ooh, a little scary, I don't know what that means. And then this one I don't know, so I put a variable for that. Okay, it could be number of, or how about your, how far under par you were. Okay, and males versus females. And let's say it's like this. This is, make this females down here, and this males, and make this people from Minnetonka. How about this? MT for Minnetonka, and let's say this is W for Wayzata. So the males from Wayzata were apparently 2 over par, and the males from Minnetonka were 7 over par. And thankfully the females from Minnetonka were way under par, which is a good thing. And then this is females from Wayzata. We don't know their data. Okay? So, basically, it's just a way to arrange data, and it could be any kind of data. Rows and columns, it's important to get the difference. Okay? If columns go up and down, rows go across, kind of like in the new target field. Here is the directory I was trying to find. There we go. Here's the new target field and how the rows and stuff go. It's not really that new anymore, but how many of you been to target field? Raise your hand if you have. Cool. I got to go once, and I got to sit in somebody else's really sweet seats. They were like right there. They were awesome seats. Anyway, but a row goes across. Okay, if you're in a row, that goes across. And columns go up and down. So if we're talking about a matrix, and I'm going to not play the matrix clip on the video. I might play it for you later, but I kind of like the clip that I found about it. A matrix is always described as rows and columns. So this one here, you'd say it's a 2 by 3. Do you get I could have said it's 3 by 2? But the reason I'm saying it's a 2 by 3 is you always do the rows first and then the columns. So it's rows, then columns. It's really important that you remember that rows go first. RC, think of like RC planes, remote control planes. Okay, it's never CR, it's RC. Okay, so rows first. So how many rows does this have? 2. How many columns does it have? 3. So it's a 2 by 3 matrix. All right. I want you to add in on your iPad, make me a 4 by 3 matrix. Use just the letter X throughout the entire matrix. Make me a 4 by 3. Both. Okay, good. And I want you to make me 4 by 3. And if you can't because your iPad's still loading, I will understand. Alright. Yeah, I see quite a bit of different ways people are doing them. There's right ways and wrong ways. 4 by 3. Alright. There's 2 choices. There's that way. Is that 4 by 3? Remember, it's rows first. Does this have 4 rows? No. So it's the other way. So you should have done it this way. And I erase this guy, these guys here. That is a 4 by 3. 4 rows and 3 columns. You get the difference. All right, this is really important. Yes. Well, I just didn't want you to have to make up numbers because that would take too long. Okay. So now, they're always rectangular. We don't have anything like a circle matrix. Okay, it's only in rows and columns. Okay, so it's always going to be squarish. Seating charts could be one. Your monthly schedule could be one. Like, you know how you go through a week is a row, and a column is like a day. So that all the Sundays are all lined up. All the Mondays are all lined up. You know what I mean? All right. So, how you format these things, sometimes they will say that an element of the matrix, like this, like the 1 right there, is in position 1, 1. What does that mean? It means rows and columns. That's why I keep saying that the row and column thing is so important. When we get to multiplying matrices, it's going to be really, really, really important. So anyway, you got to get that it's always rows and columns. Rows, columns. And if I asked you, what was that 0 right there? What's that guy's spot? I would say he's in row, what? 2, column, what? So we could say he's in 2, comma 2. Now that is different than what you're used to. What you're used to is like X and Y. This is not X and Y. Don't think of it that way at all. It's rows and columns. All right. Let's move on. Uses for them. You see this giant set of 3 equations? Did you see something like that being on the ACT test? It can be. And you either have to solve it by hand, which is a long, painful process, or you have to know how to put it into a matrix. And we will show you how to do that. And it's one of those things that'll really be cool if you come across that problem on the ACT test. You just got to put it into a matrix and then do something on your matrix called reduce row echelon form. It's just like a little function you do to it. And poof, it'll tell you the answers to what is X, what is Y, and what is Z. They can solve it for you. Bam. All right, and it'll save you a ton of time because this kind of a problem is meant to cost you like 5 minutes, and you can do it in like 2 minutes, maybe even 1. All right, so let's make sure you get what's going on here. 2x gave me the 2. 3y gave me the 3. Negative z gave me a negative 1. And the 6 gave me a 6. Do you get what's going on there? They're just plucking off the starting numbers. All right, so the starting numbers are also called the coefficients. So this is negative 1, negative 1, negative 1, 9. There they are. Get that? They have to be organized, though. You can't just have this one be x, y, z, and then this one be z, y, x. You can't do that. They have to all be lined up. All the x's have to be first. All the y's have to be in the middle, and all the z's have to be last. And then the numbers at the very end, after the equal sign, they can't have any letter on them. They have to be what's called constants. All right. So this is a use for a matrix. Is you take a set of equations like this, and you make a matrix for it, and then you can do something special to solve the matrix. All right. Let's look at this. This is what we're going to do a lot of today, which is just taking this and making points out of it. Do you get that that can't be a normal point? Do you get how a row cannot give you a normal point? But do you get how a column could be giving you a point? 1, comma 2. 1, 2. 1, comma 2. Right there. And therefore, what should that be? The point negative 2, comma 1. And is there a point at negative 2, comma 1? Oh, yes, there is. You get what's going on there? So that's just 4 points that they gave you. All right. Next. Oh, wait. There's something more. Lower on? Oh, I guess not. We'll talk more about the points in a minute. This is just adding and subtracting matrices, and it is really easy. I want you to shut your iPads for a second. Waiting. Okay. And this and this can go together. Do you get how they like naturally go together? And then if this in the middle just tells you to add, then what's the answer? 7. And then do the middle ones. And do the last one. That is a matrix answer. And the answer is a what by what. Be careful. 1 by 3. Row 1, 3 columns. It's a 1 by 3 matrix. Because it's got 1 row, 3 columns. With that, so it's 1 by 3 matrix answer. This one answer is going to be a what by what matrix. 2 rows, 3 columns. 2 by 3. Yep, this is a 2 by 3 matrix. And the answers for it will be, well, you take the 1 minus the 3 and you get negative 2. Get the idea? It's as simple as that. And then sometimes, to make it extra tricky, they'll like put this, this will be like an n. And what do I do if I have a 5 minus an n? You'd have to write 5 minus 1. But then what if they told you the answer over here and said it was 4? Then you just figured out that it was 1. What do you mean? Because 5 minus the 1 would be 4. All right. And then moving on to simple multiplication, we do scalar multiplication. That's where you just are scaling it. If I scaled you up to twice normal size, wouldn't it be awesome if there was an option to do that? Everybody could play basketball very well. It's not. It would definitely help so to be though. One of the things right now, just so you guys know, rowing has become this really, really popular sport. Got some rowers over there. All right, and I know somebody that goes to Orono High School. I won't name any names, but my son goes. My three kids go there, and this girl is really tall and really strong, and just took up rowing last year, and is already getting a full ride scholarship to go to college for rowing. Because basically, if you're tall and strong, you have a huge advantage over other people in rowing, just from the physics of it, just the mechanics of it. So it really is it's if you've got athletic ability and you're tall, they apparently are even giving some scholarships to people who they're like college, no, high school basketball players, and if they're really tall and strong, and you can figure out the coordination to do it. You can. There's a lot of scholarships being had by people who are, like, if you want to get a basketball scholarship, you have to play since you're like 3, and be really good, really, really good. But if you're going to get a rowing scholarship, there aren't that as many rowers out there, so it's easier to do that, especially if you've got that tall person. Anyway, so this is scaling this up to 3 times as tall, or big. And so all I have to do is times it by 3. So 7 times 3 is 21. 0 times 3 is 0. 3 times 2 makes 6, and 3 times negative 4 makes negative 12. And there's my answer. So scaling up, or scaling this actually down, because all of them will turn negative. It's really easy. Just take this times everything, and you get your answer. All right. This one is a triangle. Now think for a second. How could that matrix make a triangle? 3 points. This point, and this point. Each column is like a point. Right? And if I were going to put that on here, make this red triangle here. Okay. Just all I have to do is find one of these points, and then I can drop my triangle down. Negative 3, 2. Negative 3, 2 would be right there. And then I can just grab this guy and move it over and say, it's probably like this. But it could be like this, and it could be like that. Does that match up with the rest of the points? Yeah. Okay, so now I got my triangle. Now what are they going to ask you to do to it besides graph it? They're going to ask you to, like, move it. Yeah, and translate it to the right or to the left. Now if I wanted to take everything and move it to the right one spot, it would look like this. Now think about that for a second. One of my coordinates changed and one didn't. Did the x's change or did the y's change? The x's changed. Because see, the y's, they're the same height. So the x's must have changed. So if I take this, only the x's, which are this way, are going to change. And what should I do to them if I want to move it to the right? Add 1. I know you think it's subtract 1 because of the whole counterintuitive thing, but this isn't an equation written out. All I have to do is move this to the right one, which means 1 has to become 2. See what I mean? So it has to go up 1. So take all of these and move them plus 1. So negative 3 plus 1 would be negative 2. 1 plus 1 is 2, and 2 plus 1 is 3. And the y's don't change at all. 2, 3, negative 2. There's my answer for moving it to the right one. Then they're going to stretch you with flipping it, and that's definitely harder. If I wanted to take this red triangle and flip it, if I'm going to flip it, there's 3 ways you can flip it. You can flip it left, right, you can flip it up, down, or you can do the most complicated one, which is a flip over the x or y equals x line. But for right now, let's just think about flipping it left, right. That's like this way. Do you get how this point right here would have to go right here? Do you get how the y did not change? So if I want to go over the y-axis, the y isn't going to change. The x will. And what happens to the x numbers? If I'm going, well, this 1 is going to become what? Negative 1. This 2 is going to be over here at negative 2. Multiply them all by a negative. Right, I bet you shut. Okay, so if I'm going to take this point and make it flip across the y, remember it's the x that's changing. The y is already the same. I leave the y alone. These numbers change. I take them all and do what to them? multiply by -1. So this will become positive 3. This will become -1, and this will become -2. And then on the bottom, they all stay the same. There is my answer. If you actually graph it, it flips. Looks like the last one here. There. Dots. Those could be hard to do in your head. A left-right flip across the axis, but you just graph the points that I gave you right here. That, double check and make sure I did them right here. -2, -2 is right there. -1, 3 is right there. And 3, 2 is right there. Yep, we got all the points right. Did I right? Yes. I actually would do the matrix part first. Yep. Because if I asked you guys to flip this across the y-axis, most of you would not have a clue, like how it should look, just like visually in your head. It's not just intuitive that it's like, oh, it's supposed to be like that. That'd be totally wrong. Okay, so it's easier if you figure out what's going on. Like, okay, if I'm going to reflect this, just take one point, figure out what it does, and it stays the same on y, and the x gets to be opposite of what it was. Once you figure that out, make all your points, and then just graph the point. All right, let's start your worksheet. Everybody open up your iPad. It looks like this. It says Matrices Day 1. All right, and the first thing is to graph the triangle. That'll be really easy. You can graph the triangle later. It's just -5, 3, -5, 3, etc. Just make your little dots, connect your dots. And then this one says, what represents the image of this triangle after a left 3? So in other words, they want me to take this and move it left 3. If I'm moving something left, that's the x. Left and right is the x. Up and down, that's the y. Okay, so if they want me to go left, that's the x numbers I'm messing with. So that means I'll take all these numbers and mess with them. What should I do with them? If I'm going to go left 3. Subtract 3. Subtract 3. Because if I want to move left 3, like this, I'll make it smaller. So that's what you're used to in the equation. Okay, get to work. Ask if you need help. That's your only homework for today. Yes, it has actually on the. It looks long, but you'll see each problem is really pretty easy. I mean, there's nothing really hard here.